Welcome to the Sixplainer. Today, we're going to unpack something that is absolutely reshaping our world, but it's happening almost entirely out of sight. You know, whenever we talk about the AI revolution, the conversation is pretty much always about the software, right? We debate which model is smarter, which one is faster, or if they should be open source. But honestly, almost nobody is talking about the physical footprint of these massive technological leaps. We are talking about concrete, water, and electricity. Okay, let's dive into this. The AI revolution is real, and it is physical, very physical. This quote from Aaron Rose in Tech-Reader magazine really hits the nail on the head, and it fundamentally challenges how we think about technology today. We're so used to just debating the abstract digital nature of AI software, but the truth is, every single one of these cutting-edge models relies on a very real, very heavy infrastructure. We're talking about local power grids, local water supplies, and raw construction materials that are quite literally being pushed to their absolute limits to keep this digital revolution running. So, here is our roadmap for today. We'll start with number 1, the illusion of the cloud. Then we'll cover the 3 main pillars: the urgent electricity problem, the quieter water crisis, and the unseen construction boom. After that, we'll look at how this is one interconnected problem, and finally, we'll wrap up with the local impact. All right, section 1, the illusion of the cloud, what we picture versus what is actually built. Whenever we type a prompt into an AI, we kind of just imagine this invisible code floating somewhere up in the ethereal cloud, instantly crunching data and delivering answers to our screens in literal seconds. It feels like magic. It feels totally weightless. But the reality? Well, it's not up in the sky at all. It's right here on the ground. We are talking about massive, sprawling warehouses, some the size of several football fields laid end to end. Inside, there are just rows upon rows of densely packed, humming servers, drawing incredible amounts of heavy industrial resources. The magic of AI actually requires a staggering amount of brute physical force.
Moving on to Section 2, the urgent electricity problem, straining the global grid.
Now, what's really interesting about this slide is this number right here, 50,000. That is the sheer, jaw-dropping number of average homes that a single, large-scale data center equates to in terms of power consumption. Just let that sink in for a second. One single building, powering just a localized segment of the cloud, requires the exact same electrical output as a small city. And the tech industry isn't just building one of these. They're planning, permitting, and building hundreds of new facilities across the US and really around the entire globe.
As you can imagine, this immense demand is pushing our existing regional power grids to their absolute breaking points. Because, frankly, these grids were simply never designed for this kind of concentrated, explosive demand. The electricity has to come from somewhere, and the race to secure it is incredibly fierce. In fact, utility companies in some regions are actually issuing warnings right now. They're telling developers that new data center projects might face waitlists spanning several years just to get connected to the grid. It's a massive bottleneck for the AI industry, and it's happening as we speak.
Section 3, the quieter water crisis. The hidden cost of keeping servers cool. Think about it like this. When thousands of computers are processing complex algorithms 24/7, they generate an enormous amount of physical heat. If they get too hot, well, they melt down. So what's the engineering solution? Evaporative cooling. It essentially functions the exact same way that sweat cools the human body. As the water evaporates, it literally pulls the heat away from the systems. It's highly effective, absolutely, but it requires a constant, massive flow of fresh water. We are talking about a single large facility consuming millions of gallons of water every single month. So the crucial point is that this creates incredible friction, particularly in water-stressed regions like the American Southwest. There's a direct, undeniable competition happening for a very limited resource. The AI infrastructure is drawing from the exact same water supply that local communities and local agriculture depend on to survive. And because of this, we're starting to see some real municipal pushback. Local governments are finding themselves having to make really tough choices between welcoming lucrative, high-tech investments and protecting their critical water reservoirs.
Which brings us to Section 4, the unseen construction boom, building the physical foundations.
Building a modern data center is not like just throwing up a standard warehouse. Not at all. It requires incredibly deep, reinforced concrete foundations just to hold the sheer weight of the servers. It requires massive amounts of structural steel and unbelievably complex, specialized electrical and cooling systems. Finding the raw materials and honestly the highly skilled labor to design, source, and assemble all of this, it's putting a sudden, immense strain on the entire global construction supply chain. And this isn't some hypothetical future issue.
If you talk to contractors and developers today, they are feeling this squeeze right now, and it's actively driving up project timelines and construction costs across the board.
Section 5, One Interconnected Problem, a Simultaneous Infrastructure Challenge. You see, the tech industry is facing a simultaneous infrastructure challenge. These are not just isolated issues playing out in different parts of the world. The pressure on the electrical grid, the immense strain on local water supplies, and the strain on construction materials, they are all hitting at the exact same time, in the exact same locations. And they are all being driven by this singular, massive surge of AI investment. For a long time, the tech industry has been a bit slow to publicly reckon with this interconnected reality, even as they rapidly accelerate the billions of dollars of investment that are driving the strain.
Section 6, the local impact, what this means for your community. Let's move to and see how this builds. Let's look at exactly how these global investments reshape local lives. AI's massive demand for power translates directly into constraints on your local grid, which, you guessed it, can drive up your monthly electric bills. That unbelievable thirst for water, it alters local resource policies, meaning municipalities are forced to weigh tech investments against everyday household and agricultural water usage. And if you're trying to build a house or even just do a renovation right now, those supply shortages driven by massive data center construction can significantly raise your local housing and building costs. So this isn't just an abstract story about the internet. It is very much a story about local economies and community planning.
And this brilliantly illustrates our final point. The AI models we use every single day might seem like they live in the frictionless, magical cloud, but the massive machines that actually do the thinking are firmly planted right here on the ground. The real world is definitely starting to notice the weight of the AI revolution. So as this all expands, is the physical address of the cloud going to be in your backyard? Thank you so much for joining me to explore this fascinating, unseen, physical world of artificial intelligence. Keep learning, keep questioning, and I'll catch you next time.